Welcome to another Quanser Café, where I'm talking with another senior member of the academic institution. This time it's John Mitchell. He is the Vice Dean of Education of the UCL Faculty of Engineering Science and also a Professor of Communications Systems Engineering in the Department of Electrical and Electronic Engineering. His research is focused on optical and wireless access systems, optical fiber access, millimeter wave radio access, as well as systems that combine both these two areas. And his work's been funded by multiple bodies in Europe, the UK Engineering and Physical Science Research Council, the European Union, the UK Technology Strategy Board, and multiple industry partners. But interestingly for us, between 2012 and 2016, he was on secondment to the Engineering Services Faculty Office, where he led the introduction of the Integrated Engineering Program. And they've led major renovations on the program at UCL, and John and I have had a number of conversations about the success of this. So I'm really looking forward to having that conversation. And actually in 2009, he was awarded the UCL's Provost Award for Teaching. So clearly you have something to offer, John. I'm looking forward to hearing about that. He's Chartered Engineer, fellow of the Institution of Engineering and Technology, and a senior member of the Institute of Electrical and Electronics Engineers. And in my experience, and all round, as we say in England, a good egg. So we've had many conversations over the last few years, and unfortunately we haven't seen each other for a while because of the pandemic. But John, welcome. Thank you for taking the time to talk with me, and looking forward to it.
Pleasure.
So, I like to start these conversations actually kind of in the area where people are often telling me that undergraduates don't have a lot of insight into what engineering is when they enter the program. Just thought, I'd ask you the question, what inspired you to start engineering? Did you want to be an engineer from a young age, or did it happen suddenly? And what inspired you?
Yeah, my father repaired washing machines and vacuum cleaners and that sort of thing, and I used to work in his shop on a Saturday and help him out. And so I was always, from a very early age, there were things to take apart, and I guess as a reasonably young child, you start working out when you take things apart, you pretty soon better learn how to put them back together again if you want to stay out of trouble. So that was always sort of in my nature, the idea of tinkering with things and then, as you see behind me, I got into playing the guitar and various other things, and sort of, building amplifiers and pedals and all sorts of things as a kid. And so that was always something that really spurred me. But I guess what has sort of followed me through was one thing that did then occur to me is I decided to do a degree in electronics. I'd was quite good at maths and physics at school, as many people as necessary to go on and study a degree in engineering. But also had that, real interest in a practical subject. And I think what has stayed with me is I went and did a degree. It was interesting, and learned a lot from it. But if I characterize it now, it felt a bit more like an applied physics degree than an electronics degree in a practical sense. Some of my colleagues could have left not knowing one end of a soldering iron from the other, quite frankly, and come out with a first-class degree. And it always stuck with me that later on when I ended up becoming an academic, that there was something that was missing. And I like some of the characterizations of Dave Goldberg, even who talk about the joy of engineering. There is something about that theory and practice coming together that does bring something of a joy. I mean, as engineers, it is fundamental that creating something, that taking what is not and using knowledge to bring something about that wasn't there before. And I think that's what inspired me as a kid as to what you could do with these bits you find, and still inspires me to this day. And I think we have, we really should in our degrees bring that inspiration that engineering is about maths and physics and science. That's undoubtedly a part of it, but that is necessary but not sufficient to be a good engineer. And the creativity, the inspiration, all these sorts of things, problem finding, problem solving are what have always excited me about engineering, and I think what we need to instill in our graduates.
Yeah, it reminds me, you're talking about your dad having a job fixing washing machines and so on. My dad, he was an accountant, and he couldn't change a light bulb or or Blood, God rest his soul, and I remember one time, back in the day, we had a rented video recorder, where you've got the big levers
Oh
that you
yeah,
push down and play and record. And one day, for some reason, I think I was about 12 or 13, I decided to take it apart. And when he came home, there's all these pieces neatly laid out, and he
mm.
couldn't afford to buy it, and it was a rental place. And I ended up doing mechanical engineering. So I guess it does stick with you from an early age. What's interesting about your research, even though it's research into unknown areas, it's a practical application that you're driving towards, in all of your communication
Mm.
aspects. But this is a nice segue into kind of discussing what you you were involved in at UCL, which is a pretty radical change to the curriculum, a big overhaul. So maybe you could give us a little bit of a history as to how that came about, the challenges you faced, and what you actually did.
Yeah, certainly. So when I first became an academic, fairly soon after finishing my PhD, there was my head of department had become involved in a project to implement problem-based learning, and it was something that had been touted by a few people in what was then the IE, now the IET in the UK, as something we should pilot to see whether it could improve engineering outcomes. And he got involved in this project. I'm not sure how aware he was of the whole field of it at the time. And I, as a young academic, was turned up. I had my 2 courses to teach, and he said, "Well, why don't you teach one
Yeah.
of these and teach it with problem-based learning?"
Oh,
And
so
I
this
was
was
really
way
quite
before.
excited.
Sorry. So this was way before the 2012. This is back
Oh, this is
as
way
a
before.
young
Yes,
prof.
this is 2001, I think. Yeah, this
Oh,
was
okay, okay,
2001 when I
okay.
first started. And I was given a third year module. And I think this is what we see a lot of some of these innovations that people try. You've got these little islands that someone's given and they can do a really good thing there. But actually, it's quite hard to expand that out and to make it broader in the curriculum. And a lot of my colleagues looked at it and they, oh, that's really interesting. I'm going back to my lectures and I'll carry on because it looks pretty tough. And to be fair, some of the students said that as well, because one thing that characterizes a lot of universities is our students are good at the games we set them. They know how to learn stuff,
Hmm.
regurgitate it in an exam, and repeat. You know, problem-based learning does set that on its head a little bit. It changes the rules of the game and pushes students. And we certainly found that in the third year it was it's high stakes, and students rebelled a little
Right.
bit against it. And so we carried on, and some of my colleagues did some other modules. We brought in some things in the we found gaps in the curriculum where we could run project modules earlier on. But we were getting to the stage where it was becoming really difficult. Colleagues in civil engineering had done quite a major overhaul. The opportunity came to move to the faculty and to lead this program as something. And I don't know that I realised quite at the time how radical it was that we took the view that if we really truly believed this was the way we should teach engineering, we should change all our programs. We should do it with a big bang.
You were filled with this notion that, okay, it's all or nothing. We're not going to do any. We're just going to just go for it.
Well, to some extent, I mean,
Yeah.
we did what I called a pilot. I mean, laughingly, it was a pilot. We had 600 students on the thing on the pilot, because the one thing we didn't know how to do was to do it at scale. We actually knew a lot of the things we wanted to do because we'd had classes of 30 doing problem-based learning. We'd had these things for 50s. But what
Right.
happens if you do it with cohorts of 600? That's
Wow.
the bit we actually needed to
To that.
pilot it. And so the concept behind it was really to say, we've got good degrees. They're people are the students coming through are getting jobs, but we could do better, and we feel this heavy maths, science starting foundation, and the projects only come later on. We wanted to, all the things we were hearing from industry of strengthening communication skills, strengthening teamwork skills, strengthening problem solving skills, problem identifying skills. We felt these are not things you can add on later. They need to be inherent, as well as getting our students in the process of design to be thinking about sustainability, global responsibility, all
Right.
these things.
Right.
You've got to start that from the beginning. It's got to become inherent. And I think what we were seeing, we tacked some of these on the curriculum, and it so often happens, these things that have come in later from ABET or UK Spec in the UK. but they need to, if the students are going to see them not as something external to what they do, they need to be integrated. And hence, I guess the integrated engineering program really was about integrating the disciplines and integrating all those
Right.
things. So, but we had a traditional university, a research intensive university. So we looked to, how there's a question of how much you can disrupt and try
Right.
and find enough room in the curriculum to put this thread of projects, this thread of skills, but also, Professor X, who'd been teaching the same class for 20 years, could carry on doing that and it would feed into these other things. But it wasn't a full revolution. But one thing that I think became clear to me reasonably early on in the design, you've got to have enough disruption to make it hurt. It's got to have an
Right.
impact. Otherwise, um, you
So
know,
did you start with the first year students and then work your way up as they move through
yeah,
the program? Was that the
yeah.
plan? And
So
how
we
many
we worked through,
just out of interest,
yeah.
how many faculty did you have kind of involved in the kind of design of this approach? Those two things are kind of interesting to me.
Yeah, that's an interesting question. So there were a number of core teams, and it's interesting actually. There was a huge amount of value in just bringing people together from departments because we'd rarely done that for any reason. The departments were
Right.
fairly siloed in most senses. There was a sort of management representing each of the departments. There were four areas that were, in the skills, the projects, the maths, and what we were calling minors that were brought together. And so there were teams ranging from 20 or 30 from different departments working on that. And then
Wow.
the departments were, I mean, what we very much described it as was a framework that there was almost, I actually wrote it as a design specification that I gave to departments, saying it's got to look like this. Yeah. And I thought I
Yes.
thought that might chime with engineers that this is the framework you've got to design your programs to.
Right.
There are
Right.
some requirements, but you can, as long as you meet the requirements, you can sort of design around it, and we can have a negotiation. So it wasn't a sort of flat, you do this, you do this, you do this. There were some bits that were specified, but
Right.
a lot of it there was a fair flexibility. So there was probably close to 100 involved in one way or another in it by the time it was all up and running, because it effectively
Wow.
probably, I mean, and who were very closely involved, and others, I mean, because we effectively rewrote the curriculum of 9 departments.
Wow. And how long did that process? I mean, did you start like the beginning of one year and implement it the next year, or did you kind of spend 3 months trying to do it? I mean, that's a lot of people in any business, but I know, and I don't mean to be disrespectful, but academics are, it's kind of like herding sheep, right? I mean, it's not easy.
I think stars aligned in that we had a dean who was making a very strong push. There were some new heads of department who came in who were, brought in with this was part of it. We'd had a new provost who was really pushing the education agenda of the university. Talked
Mhm.
about we're a very powerful research institution, but we probably there's areas of the teaching we should do better on. So I think that there was that whole sort of structure around it, that it was something that was being talked about and was there. We spent pretty much 18 months designing the whole
Okay.
the framework of the first and second year, and then rolled out a first year while others were working on the second year.
Okay.
The major changes were the first 2 years, and then most go off into streams and
Right.
specialisms and
Right.
that sort of thing later on. As well as, I mean, so actually it's probably about half of the first year is entirely redesigned, and half of it was made up of what was there, but mixed up, and some took some departments rearranged things a bit more. Others took it as an opportunity to have a real rethink of things. Our chemical engineering department really stripped down their whole programs. And I think one of the things that when I tell people that, it's about how can you change a program so sufficiently. I mean,
Right.
I think the truth is that it's you throw everything up in there. Of course, actually, 80% of it lands back down again. What being an engineer has not fundamentally changed. There's still a
But
lot of
it
the same stuff there.
but it's interesting. I mean, you had somebody driving it. You had clearly a number of people who
Mm.
wanted the change. You saw the value of the change. You saw
Yeah.
the benefits, and we talked about, one of the outcomes of this is the students are able to develop professional skills, teamwork, communication,
Mm.
milestones, deadlines, and sharing of responsibilities, and those are kinds of things which are part of the outcome. but how do you put that all into a curriculum that's already so full? And I was really interested in your description of how you did it with the Post-it notes. I mean, you had lots of sessions to try and eliminate some of the things that maybe were unnecessary.
Well, I think, yeah, I mean, I think that's fundamental to design. I mean, one thing we did find was that actually, most people do not know. There's very few people in the department know the whole of the curriculum intimately. They know their strand or their discipline. Maybe the director of studies or the head of years knows bits, but actually to see the whole thing. So I took an approach where I broke the syllabus, wrote it on. I got known for these big Post-it notes, which are great for things in all different colours, and just mapped out the whole first 2 years and posted it on a big wall, and then brought in sort of the key team from the departments that were working on it, and got them to just take a look at this, think about how you would organise it. And what we discovered was, they'd look at me like, well, why is this Post-it note 3 times? It's like, well, it's in 3 modules. Or are we still teaching that? It's like, well, your syllabus says you are, and these sorts of things. And think about how you can bring it all together in a slightly different way, because I think, we design curriculum early on, but then they do evolve organically, and in some cases it will depend how long that organic evolution has been going as to how many tendrils grow, and a little bit of pruning. As academics, we are very good at adding stuff in. We're not very good at taking things out.
Right. And that's
it's almost an admission of failure if something's no longer important.
I would get the sense that the success you've had. I mean, we talk about the benefits, and I loved your story about that title. Maybe you can share with everybody. How to change the world, or what was the how to change the world.
So we had in big orange letters across the faculty. One of the new deans was sort of, we need a strap line, and change the world became the faculty strap line. And we were trying to think of something as a sort of capstone project of the 2 years, because our students are doing this succession of projects, and at the end of the 2 years we wanted something big, 2-week at the end of term, where they looked at UN sustainability goals, interdisciplinary teams. We were playing with ideas from this, and we were trying to find ways of framing it. But through to pollution, sustainability, anything you design as an engineer, computer scientist, will impact people, and you need to understand that impact that you're having on people. And there was a group who just didn't want to engage with that concept. We code, we program, we do this, but this is not our discipline, these people. And there was a small group who were very vocal in the first run of it. But they got through it. It seemed to go well. And then after the end of the summer, I bumped into one of them in the lift who'd been particularly vocal on it. He said, I've just come back from a job interview. And he said, and I'd put how to change the world on my CV, and I could see they'd highlighted it. And it was the first thing they asked when I went in, what on earth is this? And so I explained, it was wicked problems, it was interdisciplinary, we had to work in teams we'd not worked, and come up with solutions and pitch ideas and all this sort of thing. And I could see them as if they were, ticking things off on their checklist as they go down. He said, I sort of thought they were going to ask me all these technical questions about, how you define a pointer in SQL or something. But no, they just 2/3 of the interview was talking about this program. He said, maybe there's something in it after all.
That's been going, and it's been in place for a number of years, and then obviously the last 12 months, everything got thrown up in the air when the pandemic hit. So how easy was it for you to continue doing those kinds of projects in the style that you did when the whole world started going into lockdown?
Oh, there were days I did think that, my life would have been so much easier if we hadn't have done this. If we just had big lectures of 300, we could post on YouTube. Life would. It is hard. It is hard. I think, I guess as we've all discovered, actually, the tools for collaborative teamwork online are still, there are good ones out there now, but they are still very much in their infancy, both in the technology, but both in, I think, people's appreciation of them. I think there's a whole host of things that have come about. I think we've had a hidden digital divide, and possibly even more than digital divide of, whether the students have somewhere quiet to study, whether they've got siblings running around when they're at home, and how they interact. I think there's a whole host of things that we probably never saw in the background of what our students do when they study, that have been brought to the fore by the pandemic. So I think, you know, it has been difficult. I think we've learned a lot of good things we can do online, but you know, I think I am still wedded to the idea that, you know, particularly a good engineering education is very difficult to do remotely, to do online. I think there's great things we can do and much that's been advanced, but you know, what I hope, what I hope we can take out of it, and if you know, if any good can come out of this, is that we will go back and reevaluate what value it is of putting, you know, students and, you know, highly paid academics in the same room together. What is the value of doing that?
Right.
And you know, if we've learned you can do it just as well on YouTube or on Zoom, we should be doing it on YouTube, on Zoom. But the things, you know, and it speaks to your industry, though, you know, the wonderful things that you do in a lab, that discovery through
Right.
experimentation and through you know, you know, creative activity in a lab. um I, I think it's so hard to replicate, and is, you know, and we need to go back and think about, well, what are we using our estate for? You know, UCL is in Bloomsbury in London, some of the most
Right.
expensive real estate in the world.
And you've
You know,
expanded out east as well, haven't you? You've
and we're
got some
expanding
buildings.
out east. Yeah, new labs coming out there, and but you know, what are we using them for? Are we using them for really adding value that can't be added in other ways? And I hope that this switch to all online has given us, you know, really valuable insight into that, of how we can create a stronger blend of the physical and the online to support our students.
Yeah, I mean, this is that. I mean, this is a conversation I have with so many people that, you know, you went from about maybe 10 or 15% of the faculty who have been trying some of these techniques to now 100% and realizing just how hard it is. But other active conversations now about, you know, how to move into the future, like what you can take away and develop.
Undoubtedly. I mean, I'm naturally a bit of a pessimist on these things. I mean, I hear a lot of people saying that, oh, you know, we won't go back. I mean, actually, I think unless there's a conscious decision not to, I think actually human nature means you do tend to fall back to the norm,
Interesting.
unless
Right.
there is pressure not to. And so I think there is a this is a really interesting point for engineering educators to come to the fore, to really say, actually, we do need to think about how we gather evidence of what worked and what didn't, and to
Mm.
make a conscious change. I mean, I think, I'm already starting seeing people, we will go back to big lectures and things, whereas actually we've seen the students really appreciate the flexibility. I mean, one thing that has struck me more than anything else in this is how our students are engaging with the online material. You know,
Okay.
you used to see students, they'd come in, they'd be in their be there for the 2 hour lecture. There'd be a video of the lecture, but rarely would, there'd be a few who'd view it, but you wouldn't see, until you got to an assessment point, and then the views of the video would spike. We're now looking at the stats of the video, and you're seeing that, students are taking, you put a bunch of 10-minute videos, they're taking 2-3 hours going through them, they're going back, they're watching it, they're looking at different speeds, they're really spending a lot of time with that material because it is there, and they can. And actually, we've been having, some of the most protracted conversations have been, how do we manage the students' workload, because they are just putting so much engagement
Really?
into the materials we're providing, which really wasn't what we expected, and it is, it seems far higher than we thought it was, or the evidence seemed to suggest it was, when they came to a lecture. It is quite remarkable.
Do you
So
think
I
that
mean,
might that be somewhat to do with the fact that they're locked down as well now, and they're not going out as much as maybe they would have done in the past, and when everything's over, they're back out partying and going to the pubs and so on. Those stats may
I
change.
yeah, I can't help but think that might be the case. It's something we do need to factor in, and think about the fact that, this more digestible form and the bite size and the way we link, where we've seen really good courses of linking, short videos to questions to test your understanding and things.
Right.
Yeah, really good engagement from students in the material, when good and clearly thought out material. Like a lot of these things, some colleagues have thought, oh, I can put my 2 hour lectures up from last year and that's online learning, and
Right.
very quickly
That's
seen that isn't the case, and we've tried to
is there is there a strong voice from the students in at UCL? I mean, do they come back and give the feedback to point out those like yourself who are doing an amazing job, and maybe some people who aren't doing quite as productive?
Yes, yes, I think our students are fairly vocal. I mean, in a way, we've created that, I think, partly from on the back of the IEP, because when we first set it up, we didn't have many mechanisms for feedback other than the fairly usual ones. And to be fair, wasn't just the IEP. I think the whole university and the whole sector has moved to student voice being considerably more important, and so there's different ways of doing this. But we were also very acutely aware that we needed to have feedback from the students very regularly because we'd made such a large wholesale
Oh,
change.
okay, so
And
that's
you
been part
couldn't
of
go a
the
term
yeah,
down the way and find out something had gone wrong. We needed to be very reactive.
right.
As my colleague who was a control engineer described to me, he said, effectively, the control system that we had decided to implement was bang bang change. Yeah.
Yeah,
And as he pointed out, the problem with bang bang control is you need to be able to damp, otherwise it oscillates.
right.
And that student feedback was our damping factor, effectively trying to keep on top of things going awry because we'd made a sudden step change.
You do realize that you're talking to someone that's in the control field. So
I know.
now my engineers, when they see this, they'll have this modeled in the software, and we'll use it to apply to one of our products as well. Actually, going back to what you were saying about students interacting, one of the things that we are really happy to see in the virtual assets that we've been providing is that students spend a lot of time doing that. So when they actually interact with the professors or the teaching assistants, the depth of what they're able to achieve is
Yeah.
much greater because they're not spending the 2 or 3 hours allocated to that particular concept. They're playing with it ahead of time, and then when they have their discussions.
Mm.
Um, so I think that's something which is really important. But you bring up a really good point. It actually, because of their natural curiosity, it's going to
Yeah.
raise the workload, right? So that's going to be a challenge moving forward.
Indeed. I mean, I think that's, again, I think it has forced many colleagues to interact with some of these technologies that they're perhaps shied away from a little bit. And I think, the world
That's
of
good.
virtual labs has moved on so much since I think many people last looked at it. And there's some fabulous things out there, and I think that's, again, where we fall back to. It would be sad to fall back to fully physical because actually, yeah, as you say, the ability of a student to test out their ideas in
Right.
where there's going to be no blue smoke is a really
And
valuable.
there's no one looking over their shoulder as well, because there's sometimes in the lab there's the fear of failure, right? You
Yeah,
know,
no, indeed, and I mean, I think the flip side of that is, democratization of some of these access that,
right?
typically, historically, that, an engineering lab of a world class university is an incredibly expensive thing.
Yes.
And there have been, limited other ways of replicating it. But actually, I think, some of the options now that will put into the hands of a much broader section of the world some of these technologies, not in quite the same way, but in a very highly functional way that is an exceptionally good approximation, is going
Well,
to be a game.
it's kind of nice actually, because one of the things that we're doing with the University of Toronto is we're working with them to find um, projects which their students can do on a level playing field with people in other parts of the world.
Mm,
So essentially they're using the same platform, and there's
mm,
not an advantage for the University of Toronto students because the others don't have
yeah.
access to it. And that's challenging. Well, it's challenging having undergrads work with people overseas anyway. Do you do
Mm.
programs like that with? Do you do undergrads working with people overseas? Is that something that you get involved at UCL?
We've had we have had some examples of it. I mean, in How to Change the World, there are sponsors for, and some of them are international, usually charity partners who will bring people in to give context to things. We have done one or two of these sort of joint projects, but it's not something we've done on a huge scale, I must admit.
Well, I mean, I I have to say, I think I first had this discussion with you about what you were doing at UCL. I think it was in Munich a few years ago, 4 or 5 years ago.
Yeah.
And I remember asking, I kind of felt a bit dumb because I remember asking you this question about, do you think this is a good idea? And I think your response was, well, we've done it, and this is how we did it. So it was quite entertaining. This was obviously a few years after Chicago, and
Yeah.
it was probably around 2015 and 2016. But um, learning about the challenges for me is really valuable because obviously, we want to work with universities all over the world. I really appreciate you taking the time to speak with me, John, because there are many conversations at these conferences which are confined to the 200 or 300 people that show up at the
Mm.
conference. And we're hoping that many more people around the world will be able to hear this and the insights that, yeah, it's tough. It's an uphill struggle. You have to fight the battles and you've got to brainstorm,
Yeah.
but it's worth it. And then you got to maintain it and keep it going. Um, and,
Very
and,
true.
and, and, and it's also interesting to hear that the pandemic, you wish you'd gone back to the 600-seat lecture.
Oh, only very occasionally. Only very.
But I
I
have to,
think.
yeah, I have to ask you. With looking at the guitars in the background, I mean, have you been writing songs during this break? Have you been able to play those at all? Are you going to get back into
Still
the
playing.
band?
Oh no, still playing a bit. It's interesting as a telecoms engineer, noticing the subtle delays. A few of us did try to get on Zoom and play, and you sort of notice the subtle timing delay, depending on how far away they are. It's actually quite off-putting in some sense. So no, but
So, have you been
thank you.
doing a little? Have you been doing that a little bit of playing with some friends on Zoom or?
On occasions, not
Yeah.
as much as I would like. I did I promised my first year saw the guitars, class of 250 first year electrical engineers, and at the end they someone piped up with a question. Oh, so you're going to play us something then? And I said, oh, well if the class average is over 70% in the first coursework, I'll play you something because the results would come out close to the end. Yeah,
Did they?
72 they got. So yeah, I had to play them something at the end of the class.
Well, I wish I'd been in that role. Well, at least you lived up to the promise. That's fantastic.
You
Anyway,
have
John,
to.
thank you very much indeed. I really, really do appreciate your time.
Very good,
It's been
Paul.
all right. Thanks a lot.